All right, this section continues on the concept of rotation. Okay, now earlier, okay, several chapters ago, when you applied a force, the object accelerated. Okay, let's say accelerate it to the right. And then recently, now you apply a force, let's say to a wheel, okay, and that wheel can rotate about some axis. So we're going to look at the concept of a torque. And that concept of a torque will allow us to ask or to answer the question why a doorknob is mounted where it is. Okay, so for example, if you have a door, okay, you're walking up to the door, they usually don't put the doorknob right there. Okay, they usually put it far enough away from the hinge that's going to rotate. So the door is going to open. Usually the door handle is over there. Okay, so we haven't used the word torque. So torque refers to a twisting. Okay, so the picture I have here is I have a wrench. Okay, there's my wrench. It's around a bolt. Okay, so let's say for all practical purposes, this person is trying to loosen the bolt. Maybe that's on a wall. Okay, so it's a regular right-handed thread. So you'd be loosening the bolt. And again, this symbol is my symbol for an axis of rotation. So when someone comes by and applies a force, so let's say they're going to push it in that direction, so that's the applied force. All right. Now, here I said that that force can cause a rotation, okay, about that axis. It doesn't necessarily cause it to rotate, but it can cause it to rotate. All right. So what I did is I took this applied force and I broke it up into its radial and tangential components. Okay, so I broke this force up because what I did is I looked at what is the tip of the wrench doing. If the tip of the wrench, or if the wrench is going to move, the tip of the wrench is going to trace out a circle. Okay, so what I did is I took this force and I broke it up into components tangent to the circle, that's my tangential force, and parallel to the radius, okay, or along the radius, that's my radial component. Okay, so imagine taking away that force and all you have left are the radial and tangential components of the force. Okay, so if now you thought of these two forces, that one and that one, acting at the end of the wrench, okay, so only the tangential component of the force is going to cause a rotation. Okay, if you're pulling on it in that direction along the radius, that's not going to cause a twisting. Okay, so only the tangential component of the force is going to cause rotation about the axis A. So torque, okay, and that Greek letter is tau. So most books on the planet use tau for torque. So the torque is a measure of the tendency of the applied force to cause rotation about that axis A. Okay, so torque only has meaning with respect to an axis. Just like it doesn't make any sense to talk about what's the potential energy of a ball. Okay, you have to say with respect to where. Okay, and it doesn't make any sense to talk about what's the work. Okay, you have to say what's the work done by the spring, let's say on a car. Okay, torque only has meaning with respect to an axis. So in this picture up here where I have someone pushing on a wrench, you can't just say what's the torque. You have to say what's the torque due to the force F about that axis of rotation. Okay, so the key word is tendency. Okay, so that implies what we're going to see is if the bolt is really is on there tight and the person's not pushing hard enough, that the wrench doesn't rotate, there's still a torque. Okay, think about it as like an intent. There has to be a tendency of that force to cause a rotation. And that tendency depends on a couple things. Obviously, it depends on how strong the force is. Okay, it depends on the orientation of the force. Okay, so the direction of the force. So in the picture above, the force is in that direction, but I could push upward, I can push in that direction. Okay, so we'll see that the torque depends on the orientation of the force. And the other obvious thing, it depends on how far from the bolt the force is applied. It depends on the distance from the axis of rotation to where that force is applied. So I just drew the exact same picture. Okay, there's my exact same picture. There's a bolt. There's my axis of rotation. Here's the same force, okay, being applied in that direction. Okay, so here's the definition of the torque. Okay, definition of torque. All right, so if someone passes by you on campus and asks you, what's the definition of torque? This is the definition of the torque. Okay, so the torque about axis A due to that force, can get rid of that, okay, due to that force is the applied force, okay, multiplied by, that symbol means perpendicular, multiplied by the perpendicular distance from the axis of rotation to the line of action of the force. Okay, so let's figure out what this line of action is. All right, so here's somebody's hand, okay, and they're pushing on the wrench. All right, so what I do is I take a geometric line, okay, that's my line of action. Okay, so it's just a dotted line, keeps on going, okay, going along the direction of the force. All right, and then what I do is I draw a perpendicular line from the axis of rotation, there's my axis of rotation, to the line of action. Okay, so here's my line of action. Right, there's my line of action, that blue line there goes all the way up to there. And so I have to draw a perpendicular line from the axis of rotation out to where that line of action is. So for example, if I drew something like this, okay, that's not perpendicular. That's not 90 degrees. Okay, so let me get rid of that. Okay, so this line right here, okay, that I drew from the axis of rotation, I hit the line of action, and right there, that's my right angle. Okay, if I tried to draw one over here, okay, hits it, that's not 90 degrees, right? That's not 90 degrees. All right, let me get rid of all that stuff. Whoops. Okay, so that's what's meant by a line of action. Okay, now what's the motivation for a line of action? Okay, so here's the person's hand. Okay, and they're pushing on the wrench. Let's say they're pushing on the wrench with a force of 5 pounds. Okay, now that wrench has no idea whether the person's finger, okay, is right there, there's their finger, or if they have a rope, okay, tied to the wrench, and they're standing over here, okay, 3 miles away, pulling on the rope with a force of 5 pounds. The wrench acts the exact same way, regardless of whether the person's hand is at that point, okay, or pushing with a force of 5 pounds, or they're 3 miles away, pulling with the same force, okay, the force along that line. Or they could be standing over here, okay, and maybe they have a pole, okay, the famous 10-foot pole, and the pole, okay, maybe the pole looks like this, okay, and they're pushing on the wrench from standing 10 feet away, okay. So the effect is going to be the exact same. There's going to be a force, okay, it's going to be a force of 5 pounds at that angle, regardless of whether your finger is touching the wrench, whether you're way over here to the left or 3 miles down here to the right. So that's the motivation for a line of action. It's the line along which the force acts. So that's a definition of the torque. So in my picture, there's my force, let's say 5 pounds. Okay, and then this picture, this line here, that's the perpendicular distance from the axis of rotation to the line of action of the force. Okay, and that line has a specific name. Okay, that line is called, well, the symbol I use R perpendicular. So R just for a distance, perpendicular to remind me that it's 90 degrees. Okay, so up here, torque is force times that perpendicular distance. And that perpendicular distance has a specific name, and it's called the moment arm. Okay, and some books call it the lever arm, and that's perfectly fine. Right? So if you ask someone, what's the definition of torque? They could give you this long-winded explanation up at the top here, or they could just say force times the moment arm. Okay, so how you find the moment arm is you just draw a perpendicular line from the axis of rotation to the line of action. Okay, so as an example here, let's say here's you, and you're trying to lift these people, okay, like on a seesaw, all right? So the fulcrum, okay, the support point, the pivot point, that's my axis A, and you're trying to lift these people up. So you're exerting a torque. So the torque exerted by you, okay, about axis A, right? Remember, torque is force times moment arm, okay? So there's your force, your weight, mg, okay? And then your moment arm, okay? Remember, that's this thing way up here. That's the perpendicular distance from the axis of rotation to the line of action of the force. Well, here's your line of action. Right, there's your line of action. Okay, so you have to draw a perpendicular line from the axis of rotation, that's that red dot there, out to the line of action. So right there, that's your moment arm. Okay, so let's say you're standing on the board, on the seesaw, okay, and it doesn't rotate. You can't lift them. Okay, well, you can't change your applied force. Okay, so how can you increase your torque? You change where the fulcrum is. You can change your moment arm. So here I move the fulcrum from here over to there. So there's my new axis A. Okay, so now the torque exerted by you, okay, it's still force times moment arm. So here's the force, same force. But now here's your line of action. That looks the same. But now you have to draw a perpendicular line from the axis of rotation to the line of action. There's your perpendicular line. Remember that's 90 degrees. So now your moment arm is huge. Okay, so that's a big distance. Okay, so you increase the torque that you exert, not by changing the force, but by changing the moment arm, and then, right, and then that would lift the people up. And I think when we talked about simple machines, I talked about like in the cafeteria when you had like a spoon or something like that, and you put whatever the mystery meat of the day was right there, and then you slammed your hand down, right? It's the exact same pictures right above. So you exert a force, okay, which means you're exerting a torque, and this thing comes flying up.